I'm Steph Stricklen with GeekWire Studios. We're here in partnership with Carnegie Mellon University School of Computer Science to talk about the incredible things that are happening in the field of computer science, specifically how it's taught academically. I'd like to introduce right now two esteemed professors. We have Mark Stehlik and David Kosbie joining us. Hi, gentlemen. How are you?
Hi, Steph. Doing well. Thanks for having us.
Wonderful. Mark, I want to start by asking you. You have a long tenure with Carnegie Mellon and with the School of Computer Science. What has been the most rewarding aspect of your time working with these students at the school?
When you say long tenure, you're just basically saying that I'm old. So I get that. Pushing past that, I wanted to be a teacher since I was in second grade, and I was helping my next door neighbor who had immigrated from Costa Rica with his family learn English in my garage, as sort of appropriate for any CS origin story. And it was just a question, I think, of what I would teach in terms of subject and what level. I was very much interested in math when I was a youngin', and never quite got over that. So math was always in the cards. I was a math major as an undergraduate at Pace University in New York. I was very interested in computing. I actually managed to take a computer science course at my high school, St. Francis Prep, which is now located in Queens in New York. We were operating on punched paper tape via a 300 baud acoustically coupled modem to a machine that was located somewhere in Wall Street. And so those were my first programs back in the day. And I was really impressed. I wrote a battleship game of all things, and I was just really impressed by what you could do. I mean, like, it was really cool that I could write a game that I could play against. I had no idea of AI or search or any of that stuff, but it was just a lot of fun. And IO was terrible, but, you know, given the day and punched paper tape. But it was a proof of concept that sort of never left me. When I started math in college, I was less interested in the continuous side of the math spectrum. I was much more interested in math as it might relate to computer science. I took a course in my sophomore year that is very similar to the 251 course that we have here, Great Theoretical Ideas in Computer Science. And that showed me a way of math that wasn't so, I'm going to say this, and I don't mean it pejoratively, but it was at the time. Basically, it was formulaic, right? You know, like, you learned how to integrate by parts and all this other stuff, and you didn't really understand why, and you didn't understand what it was doing. But, you know, on the other side of the house, the discrete side of the house, it was just a lot of fun. It was proof. It was interesting. It was motivating. It was related to stuff I was interested in. Maybe it was faculty who were teaching it. Maybe it was content. But I decided that the computer science part of math was the part I wanted. And so I ended up being a math CS double major. And, you know, the rest is sort of, I don't know, history. But the thing that's never really changed is inquiry, interest in learning, right? That was true when I first started teaching. My first teaching gig actually at Pace was when I was in my first year of the PhD program here, and I was teaching night calculus to people from Wall Street so that they could go finish their MBAs. And it was like teaching calc to my dad. And that was a fascinating experience because it, A, helped me understand that you're not going to teach everybody everything and everybody's not going to get an A. And B, the important part is, can you teach everybody something? And so that part of teaching has never really changed for me. The idea isn't to get everybody to the same place. The idea is to move everybody from the place they're in to a better place. So the teaching part of my career has, I think, been just that, right? Trying to move people along, get the good students to be better, get the poor students to be good, right? Get the failing students to pass, right? And if you can do that across that broader spectrum, then I think you're a teacher. And so that part has always been the fun part. The context has changed over time. I've taught in probably 5 or 6 different programming languages. So has David. We have been together for at least 3 of those, which has been a lot of fun. So we've really enjoyed, I think, teaching intro courses precisely because of that, right? We're not teaching courses that people take because they want to be there necessarily. Many do, but we are teaching courses that people have to take in order to move on in their chosen degree path, whether it be computer science or something else. And so I think that presents a fairly unique challenge, but a challenge that I think we both embrace.
Mark, the way you describe it immediately makes me wish I had taken one of your courses. I can see your passion when you talk, but I have to tell you, when you mentioned the 300 baud modem, it is like an immediate visceral response because I can hear it and it just takes me right back. David, I want to ask you, what got you into teaching?
Well, gosh, a lot of the same things as Mark, but of course the details are a little different. Certainly our paths were different getting here. When I was younger, I was going to be a doctor, a medical doctor, and I did pre-med in college. I took computer science courses just for fun. They had no bearing on my academics. Courses like compilers, which had a lot of bearing on my lack of sleep for a half year. But it was always just a hobby. And then my senior year, something funny happened. I realized I did not want to be a doctor. And so I just didn't take the MCATs, which I was prepared for. And then I didn't know what I was going to do, only what I was not going to do. And it turns out you have to do something. So because I took these CS courses and was pretty good at it, I went to grad school at Carnegie Mellon. Got in their PhD program, and that's where I met Mark. We met playing football together, actually, on our graduate intramural football team, which we won, by the way, 3 championships. And I'm not bragging that the fraternities lost to us, but they were not happy. I'm bragging. But anyway, they were not happy. Okay, so
I should interject.
I go to grad school.
The name of our team was the NC Completions.
Okay, that wins, by the way, just by itself.
So I wrap up grad school and I went to work in industry at Microsoft. When I was in grad school, I was working at Apple, afterwards Microsoft. And then I had our first child. Well, my wife had her first child. And then our second. And upon our second, she informed me of the fine print in the marriage contract that said, upon the birth of the second child, thou shalt move back to Pittsburgh, which I had overlooked. And so I was 35 years old and moving back to Pittsburgh, and it was an opportunity to try something new. I'd always loved teaching, although I hadn't thought of teaching computer science per se. But, with my background in computer science and Apple and Microsoft and whatnot, it was natural to teach computer science. I spent the next 5 years teaching high school computer science, which was I just loved every minute of it. I was just really inspired by the impact that computer science was having on my students. It wasn't just that they were learning hard material, although there was that. It was transforming them. It really was. We'll talk more, I'm sure, over the next while about problem solving and other aspects of teaching CS. But they weren't just learning for loops. They were learning a new way of thinking, a way of precise thinking, a way of problem solving and breaking problems down into sub-problems, which we call top-down design, a methodical approach that was powerful. But beyond that, they were learning to become creative. And to get right down to the bottom of why I love teaching, it comes down to, and this is going to sound weird, but the tears, okay? Because Mark and I have seen lots of tears over the years. And they happen twice. They happen at first because this stuff is darn hard. And a lot of students are very used to just acing everything and rolling through their academics, just hit a wall. And they're not used to it, and they're not equipped for it, a lot of them. And especially in a first course, and I love teaching the first course, as does Mark. So at CMU, that would be 15112, but it's 1,000 CMU students a year take this course. And in high school, of course, you get the same experience. And if you have a high enough level of rigor, the struggles are going to be significant. And, we're not doing it to produce tears. That would be cruel and weird. They're just a side effect. And so part of the job is helping young minds deal with adversity. Okay. And I wasn't so good at it at first. My first teaching experience at CMU went woefully wrong. And I was gonna leave and go back to high school. Mark, who'd hired me into CMU, actually convinced me to stay. And I stayed, and things got dramatically better. But what I did, I actually straight up studied Mark and some other professors here, like John Mackey, and studied how they're doing it. And I realized you can't just teach the topic. You got to teach the student. And you got to really invest yourself in the whole student. And so these tiers of suffering, of challenge, of struggle, we help them through it. They get to the other side, and they're dramatically stronger as people and as students for it. And then they double back. They come back to us some years later. And then we see the second set of tears, the tears of joy. And I'm telling you, this happens all the time with Mark and me, where students come back and they're just so happy for what this has done, how it's impacted their lives, and how they've been able to impact others with what they've learned. And just nothing is nearly as gratifying to me. Nothing I did in industry comes close to the enjoyment I get out of teaching. Having said that, also, it's not like every time is a success. So the lows are lower, but the highs are much, much higher.
I have found for both of you in my research, you have done a remarkable job of helping make sure that students are well prepared for what's coming when they start attending the School of Computer Science at Carnegie Mellon. You both work on the CMU CS Academy. Can you tell me about that, Mark? I'll start with you and then David to get your perspective next. Mark, tell me how this helps students, really not just within the confines of the university, at this point globally. Tell me about that.
So David and I, for a long time, had a vision to get 15112 out to the world. In part because, as David has described it, it's not just a course in learning how to program. It's learning how to think. It's learning how to be creative. It's learning how to solve problems in a creative environment, right? So that's a perspective that we have in class, and we wanted to share with the world because we thought it was valuable. Problem is that the world isn't really necessarily ready for the first course in computer science at Carnegie Mellon. I mean, think about that for half a second, right? A lot of people in the world apply to Carnegie Mellon. Many do not get in. Many should get in, but that's a whole other story. We only have so much square footage available on campus. So trying to get this experience out into the main was our goal for probably about 15 years or so, dating back from where we are right now. But there were a couple things that were standing in the way. One was to get CMU to agree to put one of our courses out into the world at a price point that the world would consume is a little different than the price point it can charge for students who are at Carnegie Mellon. A second, as I've already alluded to, is the world wasn't quite there yet, right? Like not everybody can do this course without some proper preparation. So our origin story dates back to fall 17 when David went to a local high school here to give a talk to a bunch of computer science teachers. And as the story goes, one of the teachers said, look, we've been talking about resources available to high school teachers for a while, but we're not computer scientists by training, most of us, right? You are at Carnegie Mellon and you are in computer science, and I'll bet if you create something, it'll be good. So literally, David came to my office that day in November, and on the whiteboard, which I would turn my phone around, but I don't want to lose the focus, we put up an outline of what CS Academy has come to be. It started with our Level 0 course, which was designed to bridge the gap between things like Scratch and block-based programming to text-based programming in Python. We then introduced the CS2 course all the way up to CS112. But we realized that we had to flip the script. We had to start getting ninth grade students engaged. So we wanted as many as possible. So we had a very low prereq bar. It was just algebra readiness. If you can do algebra, you could take our course. We wanted it to be engaging. So we made sure that it was graphics based because we knew graphics was a win in the engagement space because our students told us that as we use graphics here at CMU. And we also wanted it to use David's point before, to build on David's point before, we wanted it to be creative. So we built in the notion of creative tasks into the curriculum so that students could create graphical images and animations of their own desire rather than just the things that we asked them to do. And so we piloted that CS1 course in spring of 18 to 14 schools and 400 students. I should say 14 guinea pigs and 400 students, most of which were part of that 40 teacher Western PA centered space that David was in the fall. But also we had a school in Rwanda through a connection with one of my advisees at the time. There was a school for Rwandan orphans of the Rwandan genocide that had been founded by his parents. And so we actually deployed two of small village in Rwanda. And our tagline at the time was that if it will run in Rwanda, it can run anywhere. And there's depth to that, though. We wanted to make sure that we could reach as many places as possible. And Rwanda is a key example there. We wanted to be able to deploy in schools that didn't have a lot of resources, that didn't have money to spend on equipment, that didn't have an IT person that would get through firewalls to cut holes that we could run on their, local computers. So that dictated a lot of design choices. We had to be web held, no install, right? We wanted to be cost not prohibitive, which means free. So we persuaded, Carnegie Mellon that we were going to be a free curriculum available to the world. We wanted to be teacher-centric to make sure the teachers were involved. We didn't want to be a MOOC, right? Driven, just to the students. We wanted the students to have their teachers in the loop. We also wanted to create better teachers. I mean, there were lots of pieces to our vision. And all of that didn't come right away, right? We learned very early on that we needed to get out in front of teachers because some teachers were going to be a little ahead of us. David can talk a little bit more about one particular anecdote there. We wanted to make sure we had professional development for teachers. It took a little while for us to spool up that part of our curriculum. And the presence of Erin Bozo, who is now our PM for teachers in our platform, has done a remarkable job at helping to create our professional development cycle, right? Which used to be in person. We would bring teachers here, but now is fully remote. But the free piece is really the important piece. We are incredibly proud that about 50% of the U.S. schools that have used our platform are Title I schools. That is a big bar for us. That's because schools don't have a lot of money in many places, right? Because of the way we finance schools in this country. And so if I had a nickel for every superintendent or principal who, when they asked me how much we cost, I said nothing, they would say, I can do that, right? That's really important. And it bears out in our numbers, right? And of all the things that I'm most proud of, I am very proud of that we are in places that normally wouldn't have access to a curriculum half as good as ours, for 10 times the price as ours. Well, an infinite times the price, because multiply by 0 and there you get my point. So, and now over the last 2 years, Carnegie Mellon, 15 years ago, we wanted this vision. After those 15 years, our third provost agreed to allow us to offer a version of CS 112, approximately, I would say 90% of what we offer here, to the world for a limited cost. A $200 price point, and most of that is because of administration, getting a transcript, stuff like that, right? A $200 price point is AP competitive with a curriculum that I will arguably say is more than AP competitive. So we have arrived now 6 years later at the place we wanted to be 15 years ago. So I think it's worked out pretty well.
David, I want to ask you at this point how many students have moved through CMU CS Academy, and then give you an opportunity to talk about that teacher anecdote, as Mark was referencing, getting ahead of teachers.
All right. To the first point, we've had now just over 400,000 students use CS Academy, and we're now going at about 100,000 a year of new students. And that's in all 50 states and in 30 countries. It's actually over 30 countries.
I think it's well over 30 countries. I think it's more like 75 or so.
It's like 75 where you're going to count 1 or 2 people in the country. Correct. As yes. We have a large footprint in like 30 countries. So yes, a lot of countries. And we just recently completed and are promoting our Spanish language version. And so we expect to have significant growth in Central and South America and in bilingual classrooms in the United States. So it sheds a light on a lot of our practices, how we were doing things then, and to some extent do now, although now we happily don't quite do it that way. But also the resources and philosophy of our program. So the teachers, when they approached us to do this, they didn't want this in some future time. They wanted this immediately. And Mark and I agreed, because how hard could it be to build this? I mean, mind you, we'd already at that point taught many thousands of CMU students. At this point, I've taught over 10,000, and Mark has advised over 10,000 and taught probably 5,000. And And so we're used to this. We think we could just roll it out. And the answer was nothing could be further from the truth because of the hard constraints that Mark said. We were trying to create content that was approachable by students with no background, that was teachable by teachers with no background. Okay? We were also providing not just graphics, but what was novel at the time, auto-graded graphics. So when students created these programs, like say Snake, the game Snake, it would be automatically graded by our system to see if it was correct or not. Relieving teacher a burden of grading and allowing a teacher who doesn't have so much experience to start teaching and learn on the job. Okay, so anyway, so it turns out these were incredibly complicated new things, and especially that autograder, but the whole system. We were understaffed because we are chronically understaffed, and we ran out of time, and the pipeline froze. Okay, so what I mean by that is we were building this plane while we were flying it. Okay, we were releasing stuff at 7 in the morning. I am not kidding. I was up all night, and then at 7:05, students were logging in and using what we just released. Okay, and then we weren't ready, and it just stopped. And imagine high school students, 400, and came to class that day, and just nothing for them, and they just couldn't do anything. And under this tremendous pressure, we were trying to fix this. It took 3 days. It was the only time we ever stopped the process. 3 days before we could go live again. Now, in those 3 days, and this is why we are so successful, there was an army of CMU students working with us. And we had these expert designers who are going on to become professional designers at the top companies in the world, like just whiteboarding designs, user interface designs, and rapidly doing iterative design and prototyping of them. And we had our developers who are also CMU students developing these designs, even though we hadn't committed to them. So when we pick a design, it'll already be in development. And we're doing all of this in parallel. And in 3 days, we pushed out over like 6 or 8 design choices, picked one, built it to professional grade and shipped it, and then put the content that we needed on top of it. Mark and I couldn't do that in 300 years. But when you have an army of CMU students behind you, you can move mountains. And that's our secret sauce. It's the students.
The way that you describe this, it feels like a movie. I could visualize this sort of documentary production of all these students, rallying around the whiteboard to help solve these problems. And what strikes me in this conversation is this is really what sets Carnegie Mellon apart from perhaps other universities, and certainly a very forward-thinking way of instruction, which is hands-on, teacher-led, but student forward, if you will, very much so an active part of teaching. And when I compare that against my limited understanding of the way, and this is, Mark, something you can speak to, the way we used to teach, it is a striking difference. What is probably the biggest difference in the way that you teach at Carnegie Mellon in the School of Computer Science that sets you apart? Mark, I'll start with you.
Well, David looked like he wanted to go first this time, so maybe I'll let David go first, if that's okay.
I have some thoughts about that. I would say rigor, problem solving, fun, creativity, and support. That's shooting from the hip. Those are the 5. Rigor. To begin with, we are going to focus on a depth of level of understanding that is hard to come by and comes at a high cost, but gives you a level of fluency with the materials that you can achieve no other way.
So, anecdote. I'm going to reserve the right to anecdotally interrupt. So, in particular, our operating systems course, every university that has a computer science program has an operating systems course. Our operating systems course requires you for the 3rd project to write a kernel from scratch to a spec. As far as I know, there's no other operating systems course in the world that does that in 3 weeks. So 3 weeks from soup to nuts, a full operating kernel. Students, this course is a 15-unit course. A unit is roughly an hour of work per week. So we're expecting the students to work 15 hours per week on this course. When they're doing the kernel, they are easily doing 30 hours a week. And woe to the student that waits until the last 2 days to try to do it all, because it doesn't happen. But when they're done, How many students in the United States in college CS programs can say they wrote a kernel? That is one, I think, outstanding example of exactly what David is talking about. And that permeates from top to bottom, right? Like every course at every level has a thing like that requires you to have a deep understanding of the fundamental essence of that course. I'm going to take a back seat and let David continue his list.
Right. Well, but it's from the first day to the last, and it adds up. Right. And by the way, it would be unacceptable for us to do this under other circumstances. It's a combination of the amazing students, the supports, the faculty, etc. But we have built this for this environment. So the first thing is rigor. It's highly rigorous. The second one is just a very hard focus at all levels on problem solving. And so it's not enough that you know how for loops work. That doesn't mean you know how to program. I mean, that would be like saying that if you know vocabulary and grammar, that you speak a language. But it does not mean that. You have to be able to use it on demand when you need it. And when you need to code is when problems arise and you need to solve those problems, right? So to show you how much of a difference this makes in curriculum, we get students all the time who show up at CMU who've had a lot of programming prior to CMU, and they wonder if they even need to take 15112. Now, some of them just don't. After all, we have students who've been multiple successful startups that they founded prior to CMU. So like, but most of them do. And what happens is we have students who say, I have a 5 in the AP. I took 3 high school courses. Why would I take 112? So I give them a problem from our first week's quiz, and they can't solve it because they haven't been exposed to problem solving. They've been exposed to more the mechanics of how coding works and not the problem solving side. And that's week 1. Okay. And so as an example, I don't want to bore you with details, but a typical week 1 or 2 problem would be nth left truncatable prime. So a truncatable prime, a left truncatable prime is a prime number where each time you remove the leftmost digit, it remains prime. So write a function that takes a number n and gives you back the nth left truncatable prime. That problem is on quiz 2 in the first week in the first course for students who are starting from square one. And with that level of intensity, rigor, and problem solving, you can only imagine, right? I mean, to put it another way, and by the way, we're not arrogant. We're not. We understand MIT, Stanford, Berkeley, et cetera. There are other world-class schools. But we absolutely believe that we are in that club, and we take it very seriously. We treat this like Top Gun. We're trying to train the very best here, and that has you do that differently. But then the next thing is fun. We take fun seriously. CMU takes fun seriously. I don't know if you know about like Buggy. You probably don't, but like we have this spring carnival, and our students build these little buggies. Calling it a buggy is a misnomer. It's like a missile on wheels. Okay. And then they race through the park in them with one of our students inside the thing staring it and other ones behind pushing it.
Even better.
And it's intense. They use material science students to build better materials to make it go faster on the outside. Mechanical engineers building like better internal systems. There's some of them now have software controlled systems. So computer science students are building that. It's an intensely intellectual action, but it's intensely fun. By the way, those things go, I think, like 30 miles an hour around the curves, even though there's no motor in them. So this idea of mixing fun with learning is just in the CMU DNA. And we put it right down into every single course. So like, for instance, in 112, we write Tetris, which you might say there's more fun things, but it's fun. It's fun writing Tetris. Our students like writing Tetris. We don't have to do it. It's not like you're going to get a job and someone's telling you, write Tetris. You do learn a lot of really good things when you write Tetris, but you also have fun. And then they write their own term projects at the end of the first course, which gets me on to the next point, combining fun with creativity. I've already mentioned creativity here, but it's worth really pushing that point, that we don't want you only able to solve the problems we've given you. You've got to be able to dream up your own problems. And there's this thing called design by engineer, where a lot of engineers, including computer scientists, they're really fantastic at designing complex apparatus and at building it, but they're really, as a group, many of them, not all of them, are kind of weak at designing things that people understand or people like. And so they design things that are amazing and yet kind of don't get the reaction they're looking for. So we not only want them to be creative, but we want them to be empathic to people and creating things that people can use and that people will relate to. And so there's this obsession starting from the first course on that. And then the last thing is support. And here I think CMU is nearly unique, not entirely unique. Okay. For example, Harvard has CS50, and David Mellon has done magic with that. And they have an army of teaching assistants. So we're not the only ones. But our model of instruction at the undergraduate level involves an army of undergraduate TAs providing support. And by an army, I mean in 15-112, we have 50 teaching assistants. And
this is 500
so,
students
yes,
in a semester.
so it's, and they work, we get at least an hour per student per week of TA time. And so that means that anytime you have a question, 24 hours a day, you can get an answer within minutes online. We have office hours 7 days a week. We just have this immense amount of supports for our students. And so we push them hard. I mean, we're very careful to calibrate that and not push them too hard, but we push them hard, but immersed in just intensive supports. Now, making that whole thing work requires, at this point, systems, right? Systems to find, attract and retain the best students to become TAs, to train them, because just because they're great students doesn't mean that they're great teachers, and to do quality assurance to make sure that they're actually, I can go on. It's complicated, but the obsession on support, in addition to those other aspects, which I think collectively makes all the difference. Our students do incredibly well in industry upon graduation, and I don't think it's only because of our good name. I think it's because companies hire our students who hit the ground running, and it's a consequence of just being in this environment for 4 years. Now, and of course, them being amazing.
Right. I mean, we're clearly privileged, right? We attract enough students to be able to, have the pick of the litter, if you will, right? And so, everybody is not built for CMU, but that's okay, because there are lots of schools for lots of different kinds of students. But we are privileged to have students who are both very bright and very hardworking, and the hardworking part can't be ignored. If all you focused on was natural intelligence, you wouldn't win the day. What wins the day is effort coupled with intelligence. Actually, a better way to put that is resources and effort is where excellence happens, right? And if you don't have both, right, then you don't get excellence. And so you have to have the horsepower and you have to be able to harness it.
You have spoken about the philosophy behind how you teach. We've talked about where the students are so integral to the success of what's happening at Carnegie Mellon University. I also want to talk to you about where the future is headed in instruction for computer science. Let's delve into our crystal ball and tell me what you see coming, the challenges and the ways that we can get ahead of this so that our workforce and all of the thinkers and the developers and the inventors of our world are well prepared for what's coming in the future. Anyone. That will require perhaps I'm sure you've considered it before, but it's a pretty heady question. Right?
So the world right now is preoccupied with LLMs, right? Generative AI and large language models, and that's going to take over the universe. It is the case, look, I started with 300 baud acoustically coupled modem on, punched paper tape, right? And we have gone leaps and bounds above that. But every time there's been a revolution, things have gotten better, but I don't know that it has made, teaching obsolete, learning obsolete, right? All these tools are still tools. And I think while students especially, have incredible access to information nowadays, that doesn't necessarily translate to knowledge. I mean, knowledge is really built from more experimentation with that information, trial and error, what works, what doesn't. And so you can have access to all the world's information, but you still have to have discernment to build knowledge. And I think what teaching does and will continue to do is build that discernment. I can give you an example. A couple months ago, last fall, I had a student come in, an alum, who was working at a company in New York and was telling me how wonderful it is to have these LLM tools where he can specify an API and it will actually generate something useful that he can then use and modify. And the key there is use and modify, and also the discernment that it was actually useful enough for him to be able to do that with. That was not true of LLMs a year ago, right? They were just not useful in that space. But it is also the case that he knew how to evaluate it, how to use what was there that was useful to him, and then how to modify what wasn't to suit his needs. If you take someone who has none of that context and give them those tools, they're still going to have a pile of nothing at the end of the day, right? So while some of these tools are going to change the way we do things, very much as the calculator changes the way introductory math is taught in high schools, it's not going to repurpose teachers in any way or repurpose education, right? I don't think we're quite in that part of the epoch yet. Maybe 100 years from now, maybe it'll be faster. I'm very bad at predicting the computational future because anything I would have bet on, hell, if I had the perfect crystal ball, I would have asked for 10 shares of stock from any of my alumni when they graduated. And I wouldn't be in this podcast. I'd be on a little desert island somewhere. Be that as it may. It's hard to predict the future because it changes so rapidly. You know, before Facebook was invented, nobody saw that coming, right? Before driverless cars were invented, everybody thought nobody was going to be driving in 10 years. I don't see that planned, that worked out very much as planned, right? Yes, there are driverless Waymos in San Francisco, which really freaked me out when I was visiting San Francisco this summer. But there's only, 100 of them, right? And they're only in San Francisco, right? Our ability to reason about how these things operate in the world has not caught up with their ability to be in the world. And I think that's still going to take a while to tease out.
AI presents incredible challenges to teachers and students right now. For teachers, it's actually lovely, but challenging. How do you use these tools to improve your teaching? Maybe you could provide tutors, like, we have that army of CMU students who are answering questions. Maybe LLMs could be the first response. And here's an LLM generated response. Maybe it's right, maybe it's wrong. But if it's right, you've been helped, move on, be happy. And that might save us money and time that we then take and divert those resources and put more into the students who need them more. So that would be great. Another thing we can do is simply we have to rethink just teaching students how to use AI themselves. So there's a lot for teaching that's going to go on. As for students, the biggest challenge now is you have this tool that effectively lets you cheat. Okay, we've changed the rules in 112 that it's not cheating in the sense of you're going to fail the course. You can use LLMs. We allow it. We just say if you do, you're going to fail the test, and then you're going to fail 112. And so you need to show newfound maturity that our previous students did not need because they didn't have this magic genie that could just answer everything for them. And now you do, but try not to use it too much or you just will not learn well. So challenges to teachers and students. I see LLMs getting ever faster, ever better, ever more powerful, and very quickly. And yet I don't see what I just said changing in the next 5 to 10 years. So they're just going to become better and more productive tools without undermining the whole edifice.
Is there something that I didn't touch on in the context of this conversation that you want to make sure we talk about? Mark, anything?
So I've been doing this for a long time. I started advising students actually as a sideline to my teaching career when we created the undergraduate program in 1988 and graduated our first cohort in 92. And they needed someone to manage that program. And I initially said no because I wanted to be a classroom teacher all my life, and I was a happy classroom teacher. And so the conversation I had with Nico Haberman, who was then the founding dean of the School of Computer Science, when he asked me why I didn't apply, I said, if you let me continue to teach, I'll consider this other thing that you have over here. And so he looked me square in the eye. God rest Nico. He was a wonderful founding dean. He said, so you're telling me that if we just let you work harder, you'll just do that? And I said, well, if you put it that way, sure. But I want to be what I am, and then I'll do this other thing. It turns out that the other thing really now has become my main thing. Advising students has become much more of the latter part of my career than teaching students. But interestingly enough, what I found is I ended up teaching about a lot more than for loops and if statements and problem solving. I expanded my problem solving repertoire to spaces that I was both not qualified for, but perhaps very interested in, right? Like if I had taken more psychology courses as an undergrad, I think I would have been much better served by the calculus that I've long since forgotten in helping students deal with family issues and roommate issues and all sorts of other unknown issues to me at the time. But teaching is teaching. And at the end of the day, it's about, again, meeting students where they are and helping them get where they want to go. I keep coming back to that mantra because it's true in all aspects. And what I've learned about students is that, students in the, 18 to 22-year-old range are about the same as they were 40 years ago when I started this. They are in the process of transitioning from being their parents' wards to being their own individuals, to creating their own identity, separate from their family's identity. They're trying to manage their expectations and desires against their family's expectations and desires. That hasn't changed in 40 years at all. It's grown a little more complicated due to lots of issues. I mean, COVID threw a huge wrench in that, and parental, both supervisory capability, right? How much of a lens they have into their kids now. Man, I don't think I would have survived if my parents had that lens into me when I was a kid. But so it's made things more complicated. But again, it's all about parents understanding that, and I would tell this to incoming first years and their parents when they were here in orientation week, which is coming up here in a week. Your job for 18 years was to create the best possible kid that you could. And your job is mostly done now, right? You've done this for 18 years, and now you should sit back and reap the rewards of that. And so your job is no longer to be captain of their ship. Your job is more like a pilot, right? So you're on the side, and when they have a problem, hopefully they'll reach out to you, and hopefully you'll sense that they're having a problem and maybe reach out to them. But your job isn't to organize their day anymore, right? I will never forget one of the first conversations I had with a parent, which is, can you wake up my student so he can go to 8:30 class? And it's like, no, that is not my job. And amazingly enough, it's not your job anymore either, right? Having them, trip and fall and pick themselves up and get along with their lives. That's what they're learning here as they separate themselves from you. And most parents got that. Some, I think, unfortunately, never really did. And, and the student, their children have the scars to bear for that, right? But at the end of the day, kids are kids and young adults are young adults. And, one of the biggest transitions that happens in college is not just learning about subjects. It's learning about yourself and putting yourself in the broader universal context that you need to live in. And that hasn't changed at all. And if anything, I mean, I'm getting a tear in my eye just talking about this. That has been a wonderful part of my life for the last 40 years. I have advised about 4,000 students, and I have so many good and so many weird memories of so many of them. My kids would tell me when they were young, Dad, you're actually a pretty good dad because I think you had a lot of examples of maybe how not to be a good dad in your past. I don't know that I want to make that public, and I'm not going to put any names attached to any of that, but I've definitely seen a lot of the human experience in a lot of ways that I never would have thought I would have been a part of. And, I'm still friends with most of them. So, maybe I actually had some value add in that space.
What an inspiring conversation. Gentlemen, I cannot thank you enough for your time. Mark Stehlik, David Kosbie with Carnegie Mellon University School of Computer Science. Thank you.
You're very welcome, Steph. It was a pleasure to be here.
You've been listening to Does Compute, the podcast that examines how computer science is building useful stuff that works. Thanks so much for joining us. I'm Steph Stricklen.